Hi everybody, welcome back to Beginning Algebra. This time we are in section 5.7 talking about dividing a polynomial by a monomial. That is our only objective in this lesson, so this is going to be a fairly short lesson. Let's go ahead and get started. I know that when we say the word divide, you're probably starting already to think about the long division process, but we will not need the long division process in this case because all we're doing is dividing by a monomial. So it's going to feel a lot more like we're simplifying a fraction, and you really won't see that long division process at all. Now, since we're going to be working with fractions, remember that when we add fractions, they have to have a common denominator, and the sum also has to have the same denominator. And we can use the same logic to separate a fraction back into separate terms. So for example, if we have a fraction that's a plus b, all divided by c, we can write this as two separate terms by saying a over c plus b over c. Let's practice with that. So let's take 2 plus 5 over 3, and let's just separate it into two terms. So we could write this as 2 over 3 plus 5 over 3. And then if we look at x plus 3z over 2y, we can write this as two separate fractions. We can write this as x over 2y plus 3z over 2y. And then you see, once you get it separated into separate terms, you'll be able to simplify or reduce each individual fraction as required. So, to divide a polynomial by a monomial, all you have to do is write the polynomial as separate terms. Each one will have the same denominator. And then you simplify each term using the quotient rule for exponents. Now make sure at the end that each term in each answer contains only positive exponents. Always remember, you never want to leave a final answer with negative exponents. So here's our first example. We will divide 5m to the fifth minus 10m cubed by 5m squared. So if we wrote this in a division form, it would look like this. 5m to the fifth minus 10m to the third, all divided by 5m squared. So now we want to break this up into separate terms. Each term will have the denominator 5m squared. So we can write this as 5m to the fifth over 5m squared minus 10m to the third over 5m squared. Now we will just simplify each term. On the first term, 5 divided by 5 will be 1. And m to the fifth divided by m to the second will require us to use our quotient rule. So we'll say 5 minus 2 is 3. Therefore, m to the fifth divided by m to the second is going to be m to the third. Then we have minus 10 divided by 5, which is 2, and m to the third divided by m to the second, which is going to be m to the first, because 3 minus 2 is 1. And again, remember that whenever the exponent is 1, we do not explicitly write that exponent. Here's example 2, and this one is already written in division form. So we have 16a to the fifth minus 12a to the fourth plus 8a squared, all over 4a to the third. And all we have to do is separate this into separate terms. So we'll have 16a to the fifth over 4a to the third, minus 12a to the fourth over 4a to the third, plus 8a squared over 4a to the third. And now let's reduce each term. So 16 divided by 4, of course, is 4. A to the fifth divided by a to the third is going to be a to the second. Then we have minus 12 divided by 4 is 3. A to the fourth divided by a to the third will be a to the first, because 4 minus 3 is 1. And then for our third term, the 8 divided by 4 will make 2. But notice that with our a's, we have something different here, because in every term we've had before, the power in the top has been larger than the power in the bottom. But here, for the first time, we have the power in the denominator larger than the power in the top. But that's okay because you remember your quotient rule. I told you before, always start subtracting with the larger number. So 3 minus 2 is 1. But because the larger exponent is in the denominator, we know that the leftover a will go in the denominator. So this is going to end up being 2 over a. So again, for our variable factors, we subtract the exponents, but we start with the larger exponent, and then we'll get a positive answer, and we'll put that positive exponent either in the top or in the bottom, depending on where the larger exponent was. Now, even though our problem started out as a polynomial divided by a monomial, notice that the quotient we got is not a polynomial because of this term, 2 over a, which has a variable in the denominator. So this answer that we got is not actually a polynomial itself. Now here's example 3, and it says divide negative 7x to the third plus 12x to the fourth minus 4x by negative 4x. So we know that in order to divide a polynomial by a monomial, we write each term from the polynomial with the monomial as its denominator. So we'll have negative 7x to the third divided by negative 4x plus 12x to the fourth divided by negative 4x minus 4x divided by negative 4x. Then let's go through and simplify each term. For our first term, the coefficient is negative 7 divided by negative 4. Now, on every other example we've worked, we've been able to divide and get a whole number for our coefficient. Here, that is not the case. 4 will not go evenly into 7, and this won't even simplify. But we know that negative divided by negative is positive. So this coefficient will become positive 7 over 4. Then let's deal with the x's. We have x to the third divided by x to the first. 3 minus 1 is 2, therefore we'll have x to the second power here. And on our second term, we have positive 12 divided by negative 4. So positive divided by negative is, of course, negative, and 12 divided by 4 is 3. So we'll have minus 3. Now let's look at our variables. We have x to the fourth divided by x. So 4 minus 1 is 3, and that will give us x to the third. Now on the last term, we have negative 4 divided by negative 4. So that's going to be positive 1. And with the variables, the x in the top will cancel out the x in the bottom. Another way to look at this is if you think about the quotient rule, the exponents are 1 and 1. So 1 minus 1 is 0, and x to the 0 is just another 1 to multiply by. So either way you look at it, this final term is simply plus 1. And finally we have example 4, which looks much harder than the other examples we've had. It does have 2 variables, but that's not really such a big deal. And it has several terms too, but that really isn't a big deal either. So the thing on this example is just mostly that it looks hard. You'll find when we start to do it, it's not really that hard. So let's go ahead and take each term from our polynomial and divide it by our monomial. So we'll have 180x to the fourth y to the 10th, all over negative 30x y squared, minus 150x to the third y to the 8th over negative 30x y squared, plus 120x squared y to the 6th over negative 30x y squared, minus 90x y to the 4th over negative 30x y squared, plus 100y over negative 30x y squared. So each term has the same denominator, and that denominator is just the monomial that we're dividing by. Now let's simplify each term individually. 180 divided by negative 30 will give you negative 6, because what happens is this is 18 times 10 and this is 3 times 10, so the 10s cancel, and 18 divided by 3 is 6. Of course, positive divided by negative is negative. Here we have x to the fourth divided by x, that's going to be x to the third. And here we have y to the 10th divided by y squared, that's going to be y to the 8th. Okay, moving on to the second term, we have negative 150 divided by negative 30. Now, negative divided by negative is positive. 150 divided by 30 is going to be 5. So this is going to be plus 5. With our x's, we have x to the third divided by x, that's x squared. And with our y's, we have y to the 8th divided by y to the 2nd, that's y to the 6th. Now moving on to the third term. Positive 120 divided by negative 30 is going to be negative 4. X to the 2nd over x is going to be x to the 1st, so I just write x. Y to the 6th over y to the 2nd is going to be y to the 4th, because 6 minus 2 is 4. Moving on to the fourth term, negative 90 divided by negative 30 is going to be positive 3. X divided by x will cancel out, and we will not see an x in this term. And then y to the 4th divided by y to the 2nd will be y to the 2nd, because 4 minus 2 is 2. And then finally on the last term, we have 100 divided by negative 30. Now, both of these numbers can be divided by 10, so that would leave positive 10 divided by negative 3, but we know positive divided by negative makes a negative term, so I'm going to write minus 10 over 3. Now, with my x's, I do not have any x's in the top, but I have an x in the bottom, so we'll still have an x in the bottom of this term. With our y's, we have a y in the top, and we have y squared in the bottom. So 2 minus 1 is going to make 1, and because the larger power of y is in the denominator, that leftover y will go in the denominator. So here is our final answer. And again, notice that because this last term has variables in the denominator, this expression would not be considered a polynomial itself.